There are many ways in which to supply material to a hammer mill. In this operation, a large hopper is used. Wood chips are loaded into the hopper at around 40 to 50% moisture. Here, a 621 case end loader is using one of our custom designed dumping buckets to load the hopper. These buckets make over the side loading of semi-trailers quick and practical. We use a walking floor trailer to unload our chips. The trailer is plugged into a hydraulic power unit. A sensor inside the hopper tells the hydraulic unit when the hopper is getting low, causing the trailer to unload more material into the hopper. In this way, the unloading is automated. After the chips are in the hopper, they are augered onto a conveyor belt. To achieve a consistent feed rate to the hammer mill, the material passes through a leveling device. It is important the material pass under a magnet, which removes any metal from the material and prevents it from being fed into the hammer mill. After the material passes under the magnet, it is conveyed up and into the hammer mill. Wood chips enter into the hammer mill through a rotary airlock and are then ground through the desired screen size. We use a Jeffries size E hammer mill powered by a 300 horse TEFC motor running at approximately 1700 RPM. After the material has been ground, it begins to make its way towards the dryer. It is forced up this tube by means of a high pressure blower from the mill. The freshly ground material accumulates in the collection cyclone so that it may be augered into the dryer at a consistent rate, where it will be introduced into the high pressure stream of hot air coming from the furnace and run through the drying system. This is the hot air intake located inside the hothouse. Air is pulled from the hothouse by a 30 horsepower TEFC motor and blown into the furnace with the high pressure blower seen here. The air travels through this pipe and into the top of the furnace. Inside the furnace, the high pressure air meets with fuel being augered in from the bottom of the furnace. Temperatures of 12 to 1800 degrees Fahrenheit are easily achieved. Here you can see the material being augered into the bottom of the furnace. An ash auger allows for the easy removal of ashes from the furnace. Centrally located is the operator's platform. As well as the controls, there are a variety of digital readouts which let the operator know vital information, such as the moisture content of material before and after drying, temperatures, feed rates, and more. Here you can see the fire through the observation window. Hot air leaves the furnace and makes its way into the hothouse. The hot air travels through this pipe and into the spark arrestor. The spark arrestor removes any sparks from the air and prevents them from entering the dryer system. This spark arrestor has been designed so that ashes can be easily removed. After any potential sparks have been taken out of the air, it travels through this duct and into the dryer system. Here the hot air meets with the freshly ground material being augered in from the collection cyclone. The hot air and material are then pulled through the dryer system with a custom-made material blower powered by a 200 horsepower TEFC motor. Located on the other side of the dryer system is the blower and secondary collection cyclone. As the blower sucks the material through the dryer system, it pushes it up this pipe and into the secondary collection cyclone. The dry material is then run through an auger with a moisture meter to ensure the material has been dried to less than 12% moisture. It is then sent to this pressure blower, which sends the material outside where it can be run through a secondary grinder or put into storage to be sold for a variety of applications, such as fuel, pelletizing, and animal bedding.